But it would be a good way to leverage the two. Gas and all that, but I mean.
Sí, sí, en teoría está bien. Es que no se entera.
¿Cómo es eso?
Porque ahí, si lees esto, le tienes que dar a los 3 puntos. No, y hacerlo de browse como de computer. Pero si lo haces, yo no sé ponerlo en modo presentación. Y antes me han venido como a explicarlo y me han enseñado a hacerlo de esta manera, que no es de esa manera.
Right. Yeah.
Y yo lo he seguido haciendo así, pero. O sea, me han dicho que no, pero yo lo he seguido haciendo así porque. O sea, la grabación de ayer se grabó. Sí.
Okay. Vale, gracias.
Meantime, he's filling out forms for the Dunkin's chief, so nobody likes that. So it, it could be a good way to leverage into a company. But yeah, I'm not, the coal thing, I do a lot of material handling. Man,
Yeah.
things that generate dust. Arizona's full of dust, dry place out there.
Yeah.
This is a lot of people, it's got a lot of dust, we got a lot of hazmats. Speed busy.
You're better than that too. Oh,
I was up in Reno.
always
doing
into
the
it, always
coffee
dust
roasting
your
thing.
summer.
Yeah, last year, right before this conference, in fact, I flew from Reno to here. We did a study for the Starbucks coffee facility. It's kind of north, I guess, of Reno. The great big Starbucks facility up there, man. It's a visible emission generating place, I'll tell you what. I'm sure you can see it from the roofs of the hotels.
I didn't know.
I think they purposely got it into another airshed, but it must have probably the airshed that blows up into the Burning Man.
Well, yeah, you north of Reno to drift over that way.
But yeah, that was an interesting study. It really was. I'm not sure how much methane is in that, but there would have been a bundle of CO engine. Running through a lot of stuff. Cut the smoke out. So people get too serious about it, gotta eliminate greenhouse gases, they're gonna have to give up their coffee and not get into that shit. No more of that. We won't be needing to do anything. That's not gonna happen. Oh. All right, so we gotta go drag some more bums in from all the way under and do what we got. All right. You guys all in, man? Best go coming.
Right. It's a bit of a second. Why am I gonna be if you have a chance to try? I do.
Yeah.
It was like it should be.
Got a hawk around.
She said. Fine. I think actually everything's cuts. Pretty interesting slides, which are. Oh, yeah, that could
No, apparently you got a rival across the hallway over there,
Oh.
but,
Yeah.
yeah, of course you gotta go across 2 pages and things.
Naturally, I think in the people sometimes you need to use the water. As an option, you pick that back.
All right, well, I think it's roll. You ready to do it?
Yep.
All righty, well, Ralph's fixing to give us a presentation here on the ability to track methane. So Ralph's the co-founder of Nevada Nano and the program manager of the methane track system that provides continuous automated quantification of fugitive emissions. After graduation from MIT with an electrical engineering and computer science degree, Ralph led the technical developments of 4 Silicon Valley startups that help reduce costs and transform operations in diverse applications in integrated circuit manufacturing and DNA analysis before he helped found Nevada Nano. As a product manager, he utilizes his extensive industry input and to create a solution that enables operators to meet their ESG goals and regulatory requirements while increasing profits, which is always a key thing in the capitalist world. So give a hand to the man.
Thank you. Did you make that all up?
Yeah, I just kind of made that.
Good afternoon, everyone. So yeah, we're going to talk today about the advantage of close proximity continuous monitoring. I'll tell you a little bit about the genesis of methane track product as we go through and show you some of the benefits of monitoring for leaks and emissions up close. So a little bit of introductions to Nevada Nano. We're based in Reno, Nevada, so it's a great ski year. If you want to come out and visit us, you can be up in the mountains in 45 minutes. We've got some fantastic backers in terms of investors. We're after back, but we've got investors, former executives from Oracle, Microsoft, Analog Devices, corporate investors from Honeywell, Emerson, and Johnson Controls. We've been around since 2004. Our focus has been on developing sensors. We got our start developing sensors for military applications. So we were doing chemical warfare agents and explosives. These are being used today in wearable devices for the military. And we're teamed up with Solid and Clear on those applications to protect our military from bad stuff out in the field. But after that, we've transitioned into more commercial products, flammable gas sensors. And so our sensors are going into products like what you see here of fixed monitoring devices, which you see on the left. Those are the kind of devices that mount up on a wall of a facility. And of course, wearable and portable devices that you see on the right there. We also sell our sensors into the air conditioning and refrigeration space. So these are applications that require all the attributes of our product, like 15-year lifetime and no maintenance required. And so those monitor for refrigerant leaks, not only for greenhouse gas, reducing greenhouse gas emissions, but also that some of the low global warming refrigerants are mildly flammable. So UL requires monitors, sensors in all of the new air conditioning systems that are coming out now. And a few years back, Oil and Gas Climate Initiative, so that's kind of a research branch of the oil and gas industry, came to us. They had heard about our sensors, our flammable gas sensors being used out in the Permian for safety applications. And they said, hey, we've heard great things about your sensors. Could you adapt those to do methane leak detection? And so we took a look at it and came up with a methane track product that you're going to hear some more about today. The foundation of that product is a sensor that we developed. It's got 30 patents on it. It's a technology we call the molecular property spectrometer. And you see it, one of those sensors there, that's a silicon chip, much smaller than would fit on the tip of your finger. And that sensor can detect a wide variety of gases. And for instance, our flammable gas sensor with one sensor, we can detect 19 different gases and do all those gases accurately without any manual intervention. So, but some of the advantages of this are that because it's silicon, it's very inexpensive. And you're going to hear that as a continuing focus throughout this talk, that our products are designed for low total cost of ownership, to give good return on investment. And this is a key part of it. So an inexpensive sensor, the 15 years of no maintenance that I mentioned. So the sensor doesn't poison, it's designed specifically not to poison, and no calibration required. So that's part of that low total cost of ownership that's required in many of these applications. It can do multiple gases, and all of that adds up to the low total cost of ownership. You know, if you've got to go replace your sensor every couple of years, and send somebody out to the field to do that, if you've got to go calibrate it every few months, you're not going to have a very viable solution for monitoring for methane in the perimeter, for instance. So yeah, that's the key to IoT type systems. This is an IoT type system that I'm going to describe to you. So Internet of Things. If you're putting thousands or tens of thousands of monitoring points out, you can't have crews running around calibrating. So just continuing on for a moment on that multi-gas sensing technology to give you some of the background there. There's a list of the flammable gases that are detected by our sensor. We actually detect many more than that, but these are the ones that is sort of the first order list, the most prominent ones that are used. So one sensor does 19 different gases, and that's because of the measurement type that we do. The measurement identifies the type of gas that we're seeing when it makes a measurement, and that allows it to be accurate for those gases. The same sensor with a little bit different software does 6 different refrigerant gases, and we have environmental compensation built into the sensor, so it's accurate in all weather conditions, temperature range for Arctic conditions, all the way up to very high temperatures and complete humidity range. It'll be accurate in all of those conditions. So it's unlike many other sensors. So when the Oil and Gas Climate Initiative came to us and asked us if we could do methane leak detection, right about the same time, there was a publication in the journal Science that said, hey, if you really want to reduce methane emissions, a new methodology, a new paradigm is needed. And they listed, I think, 7 or 8 things related to that paradigm. So you've got to have low cost, real-time sensors. That's low cost to make it economical and feasible for the oil and gas industry. Real time to provide continuous monitoring so that you're getting the biggest reduction. You want it low cost so that you can do an array of sensors so that you can comprehensively monitor a site or a refinery or a compressor station, whatever it might be. 24/7 monitoring. So, while you and I are sleeping, while the repair crews are sleeping, that system is still out there monitoring. So it's always on duty. Utilize the cloud for data analysis so that all the stakeholders can jump onto the system and understand how the company is operating. How is the emission reduction plan going? And mount the sensors near potential leak points. This is going to be the key focus of the talk today, is what are the benefits of mounting sensing points near the problem areas. All of that sums up to enable early detection and localization of the leaks so that when you go out to repair something, you've got a very good idea of where it is before you even go out. And that also sums up to, the best way to achieve fast mitigation times and reduce the amount of methane going up into the atmosphere And also, if you're able to sell that gas, eliminate, make sure that you capture the profit from that gas. So what we designed was designed with the help of the oil and gas industry. So we started out by surveying 10 different oil and gas companies, understanding their needs. So they helped design the system in a way, so it's designed by them and for them. And we call it Methane Track. And just like we just described, you see an array of sensor points here. So the white triangles are the different sensing points. You see a little radio signal coming off of those points. And the way it works is that if a leak develops at one of these sites, maybe a leaf hatch is left open, the wind will push the plume toward some of these sensing points. So anytime a sensing point picks up some methane, it's going to relay the information to a gateway, and that will go up to the cloud. Each site also has an anemometer included. That information goes up to the cloud as well. The anemometer tells you wind speed and wind direction. We use that in calculating where the source of the leak is. And it's fully automated, so these sensors are monitoring all the time. They also have built-in self-test features, so they can test themselves to make sure they're operating correctly. And because they're always on, always detecting, you can actually achieve up to 99% fugitive emission reduction, because you know immediately that there's a problem. They're designed to be, Quad O, A, B, and C compliant, for continuous monitoring, and even achieve the load detection limits that are sometimes required in those applications. And they're designed to improve profits, with the low total cost of ownership that I've always mentioned. Improve safety, because now this is a automated mechanical process that is part of the digital transformation. You're not having to send out to the field to do leak detection when you've got an automated monitoring system. And so you've got improved operational efficiency. Looking at that system a slightly different way, you see here a monitoring point, a sensor mounted up on a pole, so that our system is intrinsically safe, so it can mount right on the equipment up close. And so it can mount on any pipes or other facilities at the site. That sensing point transmits encrypted data up to the cloud, and we're cloud agnostic. We can install it on your cloud or any of the other clouds that are available. And then we provide the analytics as well to interpret the data that's coming from that array of sensors. So we've developed something we call leak source isolation, and that uses the wind data and all of the sensor data to calculate the leak location, leak size, and calculate total emissions for the site. And then, of course, there's a user interface that pushes out alerts to whoever you need to have alerted, whether they're text messages or email messages. It provides emission statistics, so it keeps track of, how many leaks there are, what the total volume and quantity of emissions have come out. It can push reports out to whoever needs them in your organization. Tells you about the repair status of problems in the field. And you can look at each site individually, or you can look at your whole operation, either on a regional basis or worldwide basis. This is a close-up of that user interface. Up in the top left there, that's real-time, global, regional, or individual status. So you can zoom down and look at the problems at an individual site, or you can understand what's going on in the whole world. Over in the top right, you see a listing of the current alerts. So they're color-coded based on the size of the emission that's happening. tells you the location, the start time, the emission rate, and how much volume of gas has been released. Down in the bottom left, you see a graph of monthly trends. How are we doing on a month-by-month basis? And over here is a cumulative graph of emissions to compare to, what are your targets for this year? You set your target in the software and it displays on the graph, and then okay, am I on track, or am I, too high, or am I going to get a bonus because I'm too low? I mentioned intrinsically safe sensors. So this is our beta endpoint sensor. You see one installed here. They install quite easily with hose clamps. And so it's a permanent installation. They're intrinsically safe, and we have global approvals from ATEX, UL, C1, D1. So like I mentioned, they can go on equipment that's problematic, or in the vicinity of equipment that's problematic. They're battery powered, so they're very quick and easy and inexpensive to install, and the batteries last five years. IP66 rating, so dust and water can't get in. And, because the sensor is immune to poisoning, that's what gives you the long life. So the concept here is every 5 years, change the battery, and you're going to get 15 years of life out of that sensing point. So what's unique about this system? One of the unique factors is those intrinsically safe endpoints. And that's unique because it enables the close proximity sensing that we're going to talk about today. And that's defined as, sensing near the emission sources. So typically when we do an installation, we do a site survey with the operator of the facility. We find out where their concerns are, where the problem areas are, and we custom design the system to match, to address their concerns. And, to give you an example of the advantages of the close proximity monitoring, the first one is that it's much higher gas concentrations when you're close to the source. I mean, that's obvious to everybody here, I'm sure. So for instance, this is a graph of methane concentration as a function of distance from the source. So this is, 0 to 6,000 ppm, and this is 0 to 60 meters. A close proximity sensor, this one is set up to be about 5 meters from the source. And the advantage of having a sensor about 5 meters from the source versus out at the fence line or something 60 meters from the source is that the concentrations are 10 to 500x higher. And there's a big range there, and that's because it depends on the wind conditions. If the wind conditions are favorable, you'll get about a 10x boost in concentration. If their wind is really high and with lots of changes in direction, you're going to get about a 500x boost in concentration. And what that means is that the detection is much easier, and it's much lower false positives. So for instance, if you're measuring out here, trying to figure out, okay, is it 5 ppm or 6 ppm or 7 ppm? That's a hard job. But if you're measuring up here, and it's 2,000, 3,000, 4,000 ppm, that's a much easier job. You're not going to miss gas that way. You're not going to get a false reading because the concentrations are so high. The second thing that's very good about close proximity monitoring is that you're going to get a much more precise source location and quantification when you take the measurements. And I'll try to illustrate that in the next few slides. The first thing to understand is that, wind in general is very variable. this is a graph of the wind direction. So this is direction on this axis from 0 to 360 degrees. So wind coming from any direction. And this is a 12-hour graph. So how did the wind vary over a 12-hour period? And what we see here is that, well, in this time period from noon until about 6 p.m., the wind was fairly stable. It was, it was moving around, but it was much more stable than it was after that. So in the evening hours, we had wind that was jumping all around. If we quantify it, though, we would see that the wind during the day was still going about 160-degree variability. So if it was coming from this wall at one moment, the next moment, it could be almost coming from that wall. So it was still, completely, maybe surprisingly variable, compared to what we think. And this is pretty typical of what we see in the field. There is a.
Sorry, is this data collected by a sensor?
Yes. Well, it's collected by the anemometer on site.
Yeah.
Yes.
So is that one anemometer per site, or do you have it on every sensor?
It depends on how, no, not on every sensor, but sometimes we'll use more than one anemometer. So for a refinery or something where you've got things that block the wind, we can use multiple anemometers. But for a upstream site, often one is fine. So about 160-degree variation, even when the wind was pretty stable. And of course, 360-degree variations when the wind was not very stable. Now this is good for point detection. That means the wind is moving around, sending the plume to different sensors. So it's a good thing in that regard. But you'll see in a moment why sometimes it's not such a good thing. And that's going to be depicted here. So this is that same wind data that we just saw, a segment of it. And this is very typical. So in this case, we've got a leak location that's leak is going to appear here. We've got a close proximity sensor, and that's about 10 meters away from the leak source. And then we've got a non-certified sensor that's about 60 meters away. So that's the sensor over here. And so about 4 seconds after the leak started, the close proximity sensor picked up the leak. It only took about 4 seconds for the plume to get from, took about 4 seconds for the plume to get from the leak source to the close proximity sensor. Right after that, the wind changed direction. And it changed direction to about 90 degrees, as you can see. There's about a 90-degree angle between these two. And so all of a sudden, that plume that was up here moved down here. And it's much more diluted, as indicated by the lighter color. And that's because the plume continues to spread out as it moves further and further away. And then finally, the wind changed again for the next 10 seconds. So it took 24 seconds for the wind to, for the plume to reach this sensor that's out at the fence line here. And by that time, that plume is very diluted, as we looked at from the previous chart. So the thing to notice here is that it's a very circuitous path. So, and it's a straight shot to the close proximity sensor, but to get out here about 60 meters, it's a very circuitous path that plume had to take.
Why is it non-certified distance?
There's a lot of monitoring systems that can't be certified because they have too complex a setup in terms of power sources and the sensor type. And so it takes a lot of work to design a system that can be certified, that can be in close to zone 0 application. Does that answer your question?
Because you have a a set of sensors that are certified and then some that are not? that are-
No, I'm sorry. Yes, thanks for asking. I'm making a comparison between other types of sensors and ours. Ours are only certified. And I'm just trying to point out the advantage of having it certified and being able to be in close proximity. Thank you. So it took about 4 seconds to reach the close proximity sensor. As you can imagine, that calculation to figure out where the leak is for that sensor is much easier than for this sensor because of the circuitous route that it took to get there. So it's a very difficult problem. So we were attending a National Petroleum Council survey a few weeks ago. And one of the complaints about point detection systems was the lack of accuracy. And this is the fundamental reason why. If you're monitoring from 60 meters away, or even in some cases, kilometers away, you've got a very hard calculation problem to do. Perhaps a problem that may not be solvable. So back to that checklist that we originally started with about this new sensing paradigm. So low cost, real-time sensors, we've got that in place. An array of sensors, because they're low cost, you can't put out an array of sensors. So we've got that checked off. 24/7 monitoring, so they're continuously monitoring. Get the cloud-based data and analysis. And because they're intrinsically safe sensors, they're able to be mounted near those potential leak points. So what we haven't addressed yet are the last 2 bullet points, the ability to early detection and rapid localization to achieve those fast mitigation times and reduce the amount of methane loss. So let's take a look at that. This again is some real data of 3 monitoring points near a source. So you see the red dot here. This is the source location. And this image here in the middle, that's called a wind rose. That shows how the wind varies over time during this leak. And so some of the time the wind was coming down here to the southeast. Some of the time it was going up to the northeast. And some of the time the wind was going to the west. And so that's that variable wind that we looked at before. And what you notice here is that, okay, sensor number 1 picked up that leak first. So we know that the wind was pushing it towards sensor number 1 at first. Then if you look at this is time on this axis. These are graphs of the methane readings as time goes on. You see that sensor 2 started picking up the leak about midway through this time period. And then sensor 3 picked it up at the end. So all 3 of these monitoring points were picking up readings at different times because of the wind changing. So that's where that variable wind becomes your ally that I mentioned earlier. So we utilize all the information from multiple sensors in our leak source isolation to be able to pinpoint where that leak is. And I'll show you an example of that on the next slide. But on this one, this is how it worked out. So those 3 endpoints, using data from all 3 of those endpoints, allowed us to calculate within about 1.76 meters the location of the source of that leak in this case. Now, what you're seeing here in the bottom right is a heat map of the likely location. So we go through the entire area of your site, and we rank the probability that the leak, where the leak came from. So the darker the color, the more towards red it is, that's where the leak is. And so the system ended up picking at the spot where the star is as the leak location. So very good, location, finding for the leak source. An example, field test, this was a field test of controlled leaks. There were 11 leaks over 8 days. And the releases ranged from 5 scuff all the way up to 300 scuff. And during those 8 days, there were no false positives reported, and that's pretty typical. Our false positive rate is in the parts of the million. All of the leaks were detected, and 10 of the 11 leaks were located within less than 3 meters. And I say less than 3 meters because that's the spec that we use for the system. We usually say that we can detect most leaks within 3 meters. And the total emissions volume over those 8 days, we were within 2%. So this goes back to the National Petroleum Council's concern about, okay, can these types of systems actually quantify the emissions? And what we're pointing out here is that because you're close proximity monitoring, you've made the problem a lot easier in terms of quantifying emissions. So, back to that checklist. The last 2 points now, early detection, rapid localization. It really enables these fast mitigation times and reducing the amount of methane. So what makes our system different overall, in summary here? First, we're using those intrinsically safe sensors that enables close proximity sensing, so we can get the sensors up close to the equipment. And that allows the quantification accuracy that's been missing from this type of system previously. The second is that we've got those long life MEM sensors that don't require any calibration. That leads to low total cost of ownership. You don't have to go out and change sensors. You don't have to calibrate sensors. And then third, those same low-cost MEM sensors allow you to put out an array of monitoring points. That makes your job easier as well. Now you're able to get much more information about your site, about the leak locations, about the total emissions on that site. A very comprehensive monitoring solution. So all of that together is designed for great return on investment and for great leak detection, quantification of emissions. So thank you, and I'll take any questions.
Great presentation, thank you. And I was just wondering for upstream versus kind of downstream refining. Downstream refining, they're kind of looking for all those different chemicals and species. Do you have a solution fit for just looking for methane, or do they all have the ability to look for all of them? You just focus on methane for the ones in the upstream more?
Yeah, great question. For upstream, we do concentrate on methane. So we fine tune our sensor just for the methane application.
Does that also bring down cost, or because if you're only looking for one, is it more simplistic, or is it more just tuning for it?
Yeah, it's in the software that is tuned for that. So we trade off being able to see a wide variety of chemicals for better sensitivity.
Great, thank you.
The price point.
Yeah, you'll want to talk to him, but it depends on volume, of course, but you can get one of these endpoints in volume for $300.
Is there a subscription based to this? Is that how you do it on the cloud? You just
Yeah,
subscriptions annually, and then I can have X number of devices for,
Right.
and then you pay as you go for more to add more, right? So I find I put them on my fence. I say 10 ain't enough. I need 15. I just go buy 5 more.
That's good.
Plug and play.
The individual sensitivity is you said, it's tuned for methane, but you can do it for different chemicals.
Yeah.
What's the
so
sensor technology?
the sensor technology is that molecular property spectrometer, so it's our own technology that that gives us a big advantage in designing, a methane leak detection system because we really understand the sensor technology. So we can make that marriage, very strong in making a sensor and making a detection point. But, the other part of your question, we can add additional chemicals later on. So this one is specific to just methane.
So what's the sensitivity? Methane.
For methane, we set this at 50 ppm. And in practice, it's eased down to 25 when we set it at 50, but that's very adequate for close proximity monitoring. And that gets you out of the noise and the errors of false positives.
So you have for your Quado ABC 0.06 kilogram per hour, you have a ideal, like you showed on the graph for, I forget, 0.8 kilogram leak, showed a graph, your ideal location was somewhere in the 3 meter.
Yeah, for 3 scuff, you want to be within about 10 meters. And if you're, for instance, if your requirement is 5 scuff, you can go out to 13 meters. You can keep stretching that out if you're looking for larger leaks. If you're not interested in smaller ones. But this has the full capability of, getting down to, the requirements that were originally set by RPD of 3 scuff.
Just mentioning training on the chemical stuff. Is benzene on that? Like I didn't see benzene on the list, but just for downstream finding sites, benzene one that could be added to the.
Yeah, it's not currently under development, but it is certainly on the roadmap.
I guess I can go over like a list of chemicals that you had earlier,
Yeah.
beginning of the presentation.
I'm gonna jump back to
Wanna go backwards? Backwards in time here?
close to the beginning. I didn't want to click all the way through. Maybe escape.
You got a ways to go.
Okay,
So where are we up in here?
any other questions? Yeah, go down, this one right here. That one up one. There you go.
This is right, that one I came in.
All right, well. Probably interesting. Here we are. So I'm hoping that you.
Check. Sorry?
Sensors.
Victor.
Victor. Yes, my name is Victor.
Name is Victor.
I'm ready to present.
We just got to exit there.
Good, how are you?
That should go right back to his presentation, I think is in there.
Am I allowed to stop? Are they still? talking
Yeah, and I
about
think
it?
you can just exit out of that. You good?
Does a good job.